Hey, it's Andrzej on Software. Today I would like to talk about a combination of two things, domain-driven design and microservices. They often come together and people talk about them as a combo. But for me, as my understanding goes, those are orthogonal concepts. So domain-driven design is about domain. It's about helping and learning the domain and explaining, reflecting the domain in the code, building a model and having the model in the code. While microservices is all about infrastructure. So it's all about scalability, different servers, maybe different technologies. It doesn't really tell much about the domain itself. So this is orthogonal, but they can be actually used together. To me, another explanation of this is with the term that I learned when I was studying software engineering. There is a concept of functional requirements and non-functional requirements. And functional requirements are usually what the user can see how the system behaves, meaning the logic. So I don't know, you have some accounting system and you want to put some limits into accounts. That's a functional requirement. Non-functional requirement, it's more about things being faster, scalable. It's about the infrastructure architecture. So things that the user doesn't necessarily see. Well, they can see this, for example, when there's a huge traffic and the application still is running, but that's kind of expected from the user point of view. There is a nice rule of thumb when it comes to microservices, that if you have microservices and you switch one of the microservices, others should still work, which is not so easy to do. So, because if we split our application into microservices, they somehow need to collaborate together. So how is this possible that others can still work? And this is where another thing comes to place, at least in my understanding, and this is how we use it in my project. And it's the whole approach behind CQRS, so Command Query Responsibility Segregation, and the idea of read models. So you have the separation between writes and reads. And if you go with microservices and you would use them together with domain-driven design, then the perfect solution for that is to express each bounded context from domain-driven design. So things like, invoicing, reporting, or inventory. This is a bounded context. So we put this bounded context as a separate microservice. And then the number of connections, of communication points between those other microservices is reduced, because between bounded contexts you have usually less communication as opposed to what's happening inside the bounded context. So once you have those bounded contexts being separated, but there still needs to be some communication. So for example, the accounting may need to know about some ideas from the product catalog, for example. But then if we use it with read models and we use this architecture, then whenever we display something, we actually have a read model as a kind of another, maybe not one read model per microservice, but this could obviously work. That would be really good. But also one microservice where you have this set of read models. So this is where the data is prepared to be displayed. And that's one place in the application, one microservice. So when it's this way, you're able to have this architecture which is around pushing data and not pulling data. So whenever, for example, accounting changes something, you can use some kind of event bus, maybe RabbitMQ, for example, to push the information from accounting to this read model microservice, to this facade, to the front end. And this also goes well according to the object-oriented programming principles. And good OOP is about, there's this rule, tell, don't ask. And it's the same for microservices. You want to push data out from one microservice to another, to others, and they can just grab this data and use it for something else, and then maybe they will propagate it even further. Which means that, for example, if you have this setup with microservices per bounded context, and suddenly the accounting bounded context stops working, then the read models, they're still fine. They are still there because they're placed in another node, in another microservice. So those are still working. So the only things that are not working is the writes to the accounting. And usually most of the applications that we tend to work on have much more reads than writes. So that's kind of acceptable in the worst case. And this is a good setup overall, I would say. So this way we can nicely combine all those things together and we can have this architecture where DDD and microservices do work together, and we have CQRS as a helpful addition to this. So we separate writes and reads. And once we separate writes and reads, there is less coupling between them, and there is less pushing information between the pulling information between the microservices. It's more about pushing the data. And I think this is a really nice setup. And obviously the big gain with microservices, I'm not a huge fan of microservices, just want to say at the end. I don't think they're needed in most cases. It's a good gain, but not often needed. But one thing that is actually useful is that each microservice can be written in under technology if it makes sense. And this is like a gain you can get. And if you keep all the bounded context in one service, in one server, then it's a bit harder. So that's better. But overall, DDD doesn't require microservices. Thanks for listening.